everyone, today we are going to start with the part 3 video, squares and square roots. So today we are going to learn about interesting patterns in square numbers. Okay, so the first one is sum of consecutive odd numbers. So you can see that if you take 1 square, you have 1. If you take 2 square, it is 4, that is equal to 1 plus 3. If you take 3 square is equal to 9, equal to 1 plus 3 plus 5. So we can say that sum of consecutive of one odd number is 1 square. Sum of 2 consecutive odd numbers, here it is 1, so 1 square, here it is 2, so it is 2 square. Sum of 3 consecutive odd numbers is 3 square. Similarly, if you take 4 square is equal to 16 is equal to 1 plus 3 plus 5 plus 7. 5 square is equal to 25 is equal to 1 plus 3 plus 5 plus 7 plus 9. If you add 5 consecutive odd numbers, you get the square of 5. Similarly, 6 square is equal to 36 is equal to 1 plus 3 plus 5 plus 7 plus 9 plus 11. 7 square is equal to 49 is equal to 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. So these are the patterns. You can see over here that if you take 4 square, so there are 4 consecutive odd numbers. If you take 5 square, it is 1, 2, 3, 4, 5 odd numbers are added. If you take 6 squares, it is 1, 2, 3, 4, 5, 6 odd numbers are added consecutively in one line. 7 square, 1, 3, 5, 7, 9, 11, 13. So 1, 2, 3, 4, 5, 6, 7. 7 are added. For example, what happens if you take 14 square? You have to add 14 consecutive odd numbers. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus and so on till you get the 14 square. So this is your first property in which we studied sum of consecutive odd numbers and the pattern of that square numbers. The second pattern in the square numbers we observe is about the triangular numbers. So how we are going to solve? For example, those numbers which can be arranged in a dot pattern and can form an equilateral triangle are called. We are going to learn the pattern of the triangular numbers. Let us take an example. The numbers which arrange in a dot pattern and form the equilateral triangle are called triangular numbers. For example, if you take 1 dot, that is 1. If you take 2 dots, 3 dots and form the triangular equilateral triangle, it is a triangular number. If you take 6 dots, 1, 2, 3, 4, 5, 6, it forms a equilateral triangle. If you take 10 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it forms a triangle. If you take 15 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It forms an equilateral triangle. Okay. So what to do? When you combine this and this, so what happens? You form a square. ये पूरा जो triangle है, you have to take over here. It forms a square. So 1 plus 3 is equal to 4. So this is 2 square. Now you take this triangle and this triangle. 3. And what you do is, you put this triangle in the reverse form. What you get? So this is 3 plus 6 is equal to 9. That is 3 square. Now you take this triangle and this triangle. 1, 2, 3, 4, 5, 6. You reverse this triangle and then you get 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So you get a square. This is 6 plus 10, 16, which is 4 square. Similarly, you can try for this. 10 plus 15 is equal to 25, which is 5. Let's come down to the third property, difference of consecutive square numbers. First of all, we'll understand the term. Difference means subtraction. Consecutive means one after another. Square numbers means 1 square is 1, 3 square is 9. So 1 and 9 are square numbers. So first of all, we need to prepare the whole table so that we can understand this whole pattern. So prepare the whole table like this, and we can see that 1 square is equal to 1, 2 square is equal to 4. So between 4 and 1, which are the non-square numbers between 4 and 1? 2 and 3. Okay. So 4 and 1 have between numbers which are non-square 2 and 3. Okay. So here you write down 2n. 2n is equal to 2 multiplied by 1 is equal to 2. Difference between square numbers. So 4 and 1. So 4 minus 1 is equal to 3. See, first of all, we have n plus 1 and n. Two numbers. Here 2 is n plus 1 and 1 is n. The solution that we have is number of non-square numbers is 2n, and the difference between the two square numbers is 2n plus 1. Let us solve how. If we take example, 2 square is equal to 4 and 3 square is equal to 9. So n is 2 and n plus 1 is 3. So which are the between numbers? 5, 6, 7, 8. And what is 2n? 2 multiplied by 2, which is equal to 4. And what is the difference between square numbers? 9 minus 4. So 9 minus 4 is equal to 5, which is 2 2s are 4 plus 1, 5. Similarly, if we take 3 square is equal to 9 and 4 square is equal to 16. So which are the in between non-square numbers? 10, 11, 12, 13, 14 and 15. Okay. So what are the number of non-squares? This is 6, we know. So 2n, 2 multiplied by n is 3 is equal to 6. And what is the difference between square numbers? 2n plus 1. 2 3s are 6. plus 1, 7. But we know that 16 minus 9 is equal to 7. You can calculate for 4 square is equal to 16 and 5 square is equal to 25 and so on. So we can understand this whole thing, difference of consecutive square numbers. The first number, let the first number be n and the second number be n plus 1. n plus 1, n plus 1, n plus 1. In between numbers of the square, 4 and 1. The between numbers is 2 and 3. Number of non-square numbers, 2. But we have the formula 2n. Difference between square numbers, 4 minus 1, 3. But we have the formula 2n plus 1. This pattern continues from 1, 2 till infinity. Whatever number you take, you can get the same answer. You can please note it down for your future reference. In the textbook it is given, but this is the more easiest method. Now we will see the squares of odd natural numbers pattern. This is your fourth pattern, and here we know what are odd numbers: 3, 5, 7, 9 and so on. So there is a pattern, uniform pattern, in which we can easily say that the square of odd numbers, that is odd natural numbers, can be expressed as the sum of two consecutive natural numbers. Let us see how. So here we have 3 square is equal to 9. So how we can do that? 3 square minus 1 upon 2 plus 3 square plus 1 upon 2. So we get 9 minus 1 is 8. 8 upon 2, that is 4, plus 9 plus 1, 10. 10 upon 2, 5, which results into this. Similarly, we can solve for the another odd number. Let us take example of another odd number. 5 square is equal to 25. You can take like 5 square minus 1 upon 2 plus 5 square plus 1 upon 2. That is 24 upon 2, 12 plus 13. These both are consecutive numbers. So we can say that the squares of odd natural numbers can be expressed as the sum of two consecutive natural numbers. In short, we can write like this also. Just pay attention. This is the general formula. If the odd natural number is represented by n, which is a odd natural number, so we can get as the expression of consecutive number n square minus 1 upon 2 plus n square plus 1 upon 2. This is the fourth pattern. This is the fourth pattern for the squares of odd natural numbers in the squares. You can try for any natural odd numbers, that is 9, 11, 22. 22 is odd? No. You can try for 15, 27, whatever odd natural numbers. Don't try for even numbers. Okay. This pattern is only for squares of odd natural numbers. Please note it down. So now let us come down to the fifth and the most wonderful pattern, that is product of two consecutive even or odd natural numbers. That pattern is also known as magic pattern. Let us see how this magic works. For example, if you take any two consecutive even or odd natural numbers, 2 and 4. Product means multiplication. Multiply them, you get 8. What is in between these two numbers? 3. So 3 square minus 1 is equal to 8. magic pattern. Just see, let us take another example. 5, 7. Multiply both 5 sevens are 35. What is in between these numbers? 6. 6 square minus 1. That is also 35. For example, let us take 10, 12. Multiply these number. 120. What is in between them? 11. 11 square minus 1. That is also 120. So we can see that there is a general formula. If this is A, this is the product A minus 1 and A plus 1. You already did this in algebraic expression. You already know that A square minus 1 is equal to A plus 1 multiplied by A minus 1. Please note it down. You can also try with another numbers and verify that product of two consecutive even or odd natural numbers has got this pattern. Note it down. Let us come down to the sixth pattern in square numbers. For example, this is very easy to understand. Just pay attention over here. It's 1 square is equal to 1. 11 square is equal to 121. Triple 1 square is equal to 1, 2, 3, 2, 1. 1, 1, 1, 1 square is equal to 1, 2, 3, 4, 3, 2, 1. 1, 1, 1, 1, 1 square is equal to 1, 2, 3, 4, 5, 4, 3, 2, 1. Similarly, we have different pattern squares for 9 digit at the place. For example, 9 square is equal to 81. Okay. 99 square is equal to 9801. 999 square is equal to 998001. 9999 square is equal to 998001. Let us see for 7 square. 7 square is equal to 49. 67 square is equal to 4489. 667 square is equal to 444889. 6667 square is equal to 44448889. So can you see that flow? So these are the few patterns that we have learned today, and here we end our video. Thank you so much. Goodbye.